standing by. Today's conference call will begin momentarily. Again, thank you so much for standing by. Today's conference call will begin in just a moment. Thank you for standing by. Today's conference is being recorded. If you have any objections, you may disconnect at this time.
Hello, everyone, and thank you for joining us for today's media teleconference about the James Webb Space Telescope. I'm Elise Fisher with NASA's Office of Communications, and today we'll have members of our Webb team on the line to discuss some of the progress made in these early stages of the months-long process of aligning Webb's mirrors. So as part of this discussion today, we will be referring to some early alignment imagery that we've shared online just prior to this call. So we'd also encourage you to view that content at blogs.nasa.gov/web. So with us today to discuss the alignment process and to answer your questions, we have Lee Feinberg, Webb Optical Telescope Element Manager at NASA's Goddard Space Flight Center, Marcia Ricci, Principal Investigator for Webb's Near Infrared Camera, or NIRCam, and Regents Professor of Astronomy at the University of Arizona. And we have Marshall Perrin, Webb Deputy Telescope Scientist at the Space Telescope Science Institute. So each of our speakers here will share just a brief update to start about where we are with mirror alignment before we move into our Q&A portion. But when we do get to that point, you can ask a question if you're on the phone lines by pressing *1. So with that, to begin, I will go ahead and turn it over to Lee Feinberg.
Thank you. Let's see. So this amazing telescope has not only spread its wings, but it has now opened its eyes. We have taken the first alignment images, and the team is already working very hard aligning the telescope. As planned, we pointed the telescope at a bright, isolated star, and we found and identified 18 spots for the 18 primary mirror segments. Recall, this is an initial phase where each segment is acting as a separate telescope in combination with the shared secondary mirror. And the initial results are very similar to our simulations. We also have performed a focus sweep with the secondary mirror and have set the focus for this initial phase. The pointing of the telescope relative to the spacecraft matches our predictions, and the individual pointing of the 18 primary mirror segments also match predictions. And at this point, we've been able to analyze multiple engineering images that help us understand the alignments and the mirrors themselves, and we don't see anything of concern. This is the first time we're getting data on mirrors that are actually at zero gravity and using starlight to illuminate the primary mirror, And again, so far our data is matching our models and expectations. The NIRCam has proven to be an excellent wavefront sensor, and the mirror actuators are performing as expected. We are just completing the image array sequence that puts the mirrors into an array that looks hexagonal, and then we will start the second of 7 telescope alignment phases. You can actually go to the blog to read about that. I want to give a quick shout out to the teams at Northrop Grumman, at Ball, L3 Harris, Goddard Space Telescope, who worked so hard to get here. I know many of them are following this. It is still early, but we are very encouraged with what we're seeing. And let me turn it over to Marcia.
Thank you, Lee. When I came into the Institute Tuesday morning, I was hoping for the very best. My team and I have worked on NIRCam for over 20 years, and the excitement of finally getting some light through the telescope onto NIRCam's detectors was really hard to express. So I came here for my daily console shift on Tuesday, and this place was a giant celebration because the light had made it, and we were super duper happy. So the very first images that we took were a quick engineering check to make certain that nothing was blocking the light path into NIRCam. We didn't want to start this big image mosaic to find all 18 segments without being assured that NIRCam was working. I mean, the filter wheels could have moved, or one mirror mount that's slightly compromised could have shifted, and there could have been reasons for not getting light in. But we got beautiful, at least beautiful to a person who's worked on NIRCam for a long time, images. And so none of the issues, problems were realized. NIRCam was working. And I have to say, the NIRCam team has been very gratified with our collaboration with the wavefront sensing team. We have all learned a lot more about optics than we knew as astronomers going into this. And the use of NIRCam as the wavefront sensor has benefited its eventual science use in several ways. First, as the wavefront sensor, NIRCam's optics have to be nearly perfect, so any imperfection in NIRCam doesn't get imprinted on the whole telescope when we sense the light. And additionally, because wavefront sensing is what we call a mission-critical function, we built 2 exact copies of NIRCam and bolted them back to back. And that means that when we go to do that science we want to do, to find those most distant galaxies, we get twice the field of view, which is a huge help. And so at this point, all parts of NIRCam are working very well. They match our predictions for the performance at this relatively warm temperature, nearly basically 60 degrees above the nominal operating temperature. And I'd like to thank all the groups that have helped the NIRCam team get to this point. My team back at the University of Arizona, the Goddard team, the Space Telescope Science Institute team, the Lockheed Martin team that built NIRCam, the Teledyne team that made our detectors, and the Smithsonian Astrophysical Observatory Mechanical Analysis team. And now I'll turn it over to Marshall Perrin.
Thanks, Marcia. So the Webb team has had, for years we've maintained engineering alignment budgets for how well lined up the mirrors should be at the start of the process in space. After all of the complex deployments and unfolding that happened last month with Webb, we expected the mirrors to be misaligned by up to about 1 millimeter, or tilted by up to plus or minus 1/4 of a degree. Because of that, those 18 spots of light could potentially be very spread out on the sky. So in this first observation, we took many images of a region of the sky about as big as the full moon to ensure we could find all 18. That was 156 different pointings of the telescope, more than 1,500 images in total. Doing that required many of Webb's systems to act together as an observatory for the first time in flight. That was the telescope and NIRCam gathering light, the software scripts on board that were controlling the telescope pointing and taking exposures, the observation planning software that we used on the ground, and the data pipeline processing the images. And for the first time in flight, all these systems acted together in the way that they will for science observations, worked very, very smoothly. And as we watched the data come down, a few images at a time, spread out over hours and spread out over the day, very rapidly we started seeing those bright spots of light that we were looking for. We were able to find all 18 segment images within the first 10% of the search area. There was one particular moment that first evening when one set of images came in, and in that next set, we put it up on the big screen, and we could see maybe 8 more segments all at once, all clustered close together, and then even more in the next image right after that. That was just a real wow moment, just lots of cheers and excitement from everybody there in the room, this tremendous excitement. And pretty soon we realized that we had all 18 segment images. The fact that we found all 18 so close together and so close to the center of the search region means that the mirrors were already pretty well aligned after those initial deployments. It's a real testament to the care and the precision with which the observatory was put together on the ground, and with how smoothly the ride to space went in all those deployments. And that has put us in a great starting position to begin aligning these mirrors to act as one. And the team has begun that process, as Lee said, and we will continue that in the months ahead. Thanks, and I'll have to turn it back to Elise.
All right, thank you all very much. So with that, we'll go ahead and begin taking questions from media who are on the line. So we just ask that when you ask your question, if you could please state who you're directing that to. If you know, that would be fantastic. And we have asked that our speakers, when they begin to respond to a question, identify themselves so those on the line know who is speaking. So with that, operator, would you please provide the instructions to ask the question and take our first question here?
Absolutely. So as another reminder, to ask a question, please on your phone and record your name clearly when prompted. To withdraw a question, you can press *2. And our first question comes from Bill Howard from CBS News. Your line is now open.
Hey, thank you very much. 2 questions for me, one for Lee and one for Marshall. Lee, is saying that you don't see anything unusual the same thing as saying you're seeing exactly what you expected at this point? In other words, you're pretty much ops normal from what you had planned out. And maybe for Marshall, the blog said the mirror temps will never be perfectly uniform with a 15 to 20 Kelvin spread between them. Does that require any reshaping of a mirror segment, or do you take that into account just by tip and tilt alone? Thanks.
Okay, this is Lee Feinberg. Yeah, I mean, I think the answer is pretty much yes. The only thing I want to caution is it's still very early, so we don't have detailed evaluations of everything at this point. But from our preliminary evaluations, everything is matching the models as well as we would expect the models to work at this point. Things are warmer. For example, NearCam as a wavefront sensor is warmer. Our ability to do some of the more detailed analysis will improve as time goes on, as things stabilize. So given where we are, things are matching the models to the level that we would expect.
And this is Marshall Perrin. The mirrors don't actually require any special adjustments given that there's a slight spread in temperature between them. We've talked before in some of the previous events and some of the blog posts about how beryllium as a material is really very stable, and so the mirror temperatures between 30 to 50 Kelvin does not appreciably change the surface of the mirrors. And in fact, when we tested on the ground, we had the JWST tested at the Johnson Space Flight Center. We replicated the in-flight expected range of temperatures there. So that's all absolutely nominal. Now, the mirrors are not yet at their first final temperature. They'll continue to cool over the month ahead, but that's all, as Lee was saying, just as we expected.
Thanks.
All right, and our next question comes from Marcia Dunn from the Associated Press. Your line is now open.
Yes, hi. Couple questions, probably for Lee. The first one, if there was some major flaw on the scale of a Hubble mirror issue, would that have popped up? Would you know about it by now? I mean, can you say that at least from a major flaw point of view, there's no indication at all from what you've seen so far? Can you rule that out? Also, I'd like to get some reaction to the mirror selfie. That was a fun picture to see. And how long do you think the alignments, when do you expect to wrap that up? Thanks.
Okay, in terms of the major flaw question, that's obviously something that we've been thinking about. It's too early to say that there's definitely not a major flaw. We're not at that point. We think that when we get to fine phasing, we'll know that we have built a primary mirror, for example, that is, meeting all of its requirements, if you will. But it is, had there been a large major flaw, I think it is possible we would have seen it now, and we don't. So that's the most I can say there. In terms of the reaction to the selfie, I think pretty much the reaction was, holy cow. And in part, understand that we never, even when we tested it in Houston, we didn't have starlight illuminating the primary mirror in this configuration. So this was actually a new thing for us. We actually used, in the test in Houston, we had special little light-emitting diodes that we put near the edge of the mirror. But we didn't see the full primary mirror in this sort of mode because we didn't have that starlight. So we were pretty much wowed by it, and that's one of the reasons I think people wanted to share it. And then I think the last question had to do with sort of in terms of the schedule and how long it's going to take. I'm going to let Marshall take that one.
This is Marshall Perrin. The expected schedule for the mirror alignment, it will take us about a month to complete the initial alignment of all the segments as seen by NIRCam, and then over the time beyond that, we will iterate that alignment to ensure it's aligned not just to NIRCam, but to all of JWST science instruments. Some of the others are not yet cold enough to operate, so that happens later in the process. We expect that the alignment process should be about 120 days after launch. One thing I can say right now is we are just about right on track. Some steps have taken a little bit longer than expected. Some have taken less time than expected, and it's all averaged out. And we're within a day or so of the initial pre-flight schedule that we expect it to be on.
Thanks a lot.
Okay, thank you. And our next question from Phil Boyd from NPR. Your line is now open.
Oh, hey, thanks for having this. I wondered if you could talk a little bit about the timing. You mentioned Tuesday. So when actually did the very first image come in? And, sort of, could you just go over the exact timeline of this? And you mentioned that it's too early to know whether there's, any flaw, like everything's looking good so far, but, it's still too early. Like, at what point would you feel like you're for sure there's not any major problem? Thanks.
So I'll answer your first question and part of the second question. So we had laid out a plan where this checkout of NIRCam was scheduled, and we made a joke out of the fact that every time NIRCam takes some important data right now, it seems to happen in the middle of the night, which was certainly true. So I'd have to go back and look, but it was early in the morning on February 2nd that we got our first light. And in terms of when are we going to know that there isn't a major flaw or some big problem, I mean, I can say unequivocally right now that the only possible gotcha for NIRCam would be if somehow there's some excess noise in the detectors. Everything else, all of the optical performance so far matches, and there's no issues. But NIRCam is much simpler to check out than the full mirror, and I'll let Lee comment further.
Yeah, and by the way, I know I started getting texts at 2:30 in the morning when the data was coming in, so I know it was just a little bit before that. I was saying earlier, what we've been saying all along is, there's these 7 phases of telescope alignment. The 5th phase is what we call fine phasing, and that's planned to complete in March. And that's when we think we'll be very confident, for example, that the primary mirror is, meeting its requirements, and that the optical system, all the mirror surfaces are correct. There still will be work to do, and we'll still have to show that our actuators have, sufficient range, if you will. But we think that's kind of the critical point at which we're going to know that we don't have a confidence as we go, and we got the first glimpse of that in the past week.
Okay. And our next question comes from Chelsea Gold from space.com. Your line is now open.
Hi, thanks so much for taking my question. My question is for all three of you, whoever would like to answer. Obviously Webb is still adjusting and cooling down and preparing for science observations, but this is a major milestone, after going through deployment, unfolding, launch, hundreds of single-point failure risks. How does it feel to have successfully reached this point? How does it feel finally getting to this moment in the process?
I'll take the first shot because I think I've worked on the project the longest and known about the risks for the longest. And so, I've committed 20 years of my life to this, and it is just unbelievably satisfying to know that a wide team, a broadly distributed team across 3 countries and many people in the U.S. have all come together and made this work.
Yeah, this is Lee. I sort of have mixed emotions right now. I think I agree that it is, after all these years, I think I've been on it almost as long as Marcia, after all these years to actually see data when we're in zero gravity in space, it is emotional. And it was, I will say in the room when we were looking at the data, people were really excited. But we still, are being a little cautious because we still have things that we have to get through. So it's kind of mixed emotions. But I will definitely say when I went home on Saturday night, a few days later, I know my wife said to me it was the first time she'd seen me smile since December. So we're all feeling, energized by all of this. Let me pass it over to Marshall.
So for those of you that watched some of the videos, webcasts of the deployments earlier, so the team then is very calm and working through steps very methodically, and that's still how we work for the most part. But when these first images came in, the facade dropped, and we were cheering and laughing, and there was applause. People were crowding around to see the images, just thrilled with where things were. It was just this incredibly exciting moment. And as the process has gone on since then, it has been. I've heard team members comment that, wow, this is just like rehearsals. This is just like simulations. Everything is going very smoothly, and we're elated and relieved, and we're happy to be at work.
Thank you. And the next question comes from Alexandra Witz. Your line is now open, and she's calling from Nature magazine.
Hi, thanks. This question is for Marshall. I want to maybe deconstruct the notion of first light a bit more. What is going to constitute first light for this telescope?
So we don't really focus on a specific first light image, because this is a process. This is an engineering alignment. We begin with internal checks of the instruments. We do these initial alignment images for the telescope. In some sense, it's all building towards the science observations. And so we really prefer not to emphasize a single first light image. In fact, if you think about that mosaic process, the way we began assembling hundreds of images together in that, there was a particular first image in that sequence, but that one didn't have any stars in it. We eventually found light in one of the later pointings. So we don't really focus on a single image as a first light, rather than the overall process of aligning the telescope.
But is it accurate to say the telescope has achieved first light, or is that not accurate?
First photon.
We have detected photons from outer space with the telescope, yes.
Okay.
Thank you. And our next question comes from Leo Enright, calling from Irish Television. Your line is now open.
Thanks very much. There's some interest here in Ireland in the MIRI instrument because Ireland is making a number of contributions to it. Can you talk about when the MIRI people will be having the same experience? When do you expect it to be switched on? When do you expect them to be hunched over their TV screens waiting for something like you had, on the 2nd of February?
So I'll take this one because my spouse, George Reiki, is the U.S. side science team leader for MIRI, and he and all of the European colleagues on MIRI are eagerly awaiting for MIRI to get cold enough to sense light. And MIRI takes the longest to come online because it has to get the coldest, and right now the cryo cooler that gets its detectors down to the operating temperature of something like 6.5 degrees above absolute zero are going through a pre-planned set of steps that all seem to be going well. But they're not going to be able to take imagery until about something like, I forget the exact time, but somewhere around this same time that Lee has quoted when we're done with the telescope alignment, around 120 days after launch.
Okay, thank you. And the next question comes from Stephen Clark, calling from Space Flight Now. Your line is now open.
Thank you, Stephen Clark from Space Flight Now. I think Marcia's response to the last question may have at least partially answered my question, which is, given the good alignment of the mirror segments and the fact that you found all these dots from the target star in the center of that search region, does this in any way accelerate the timeline to align the telescope and get through commissioning, or are you still at the mercy of cooling down the telescope and getting down to your operating temperature before you can really finish that?
Yeah, we unfortunately it doesn't necessarily speed us up. There are other things that have to cool down, like the guiders. That's coming up. They have to get to a certain temperature before we can guide. The other really critical thing for us is we have to have the structure that holds the mirrors achieve a certain stability. And that'll be one of the things we're waiting for later. So the whole philosophy of the telescope alignment team is to keep up with the laws of physics, which means we don't want to be the thing holding it up. We want the cool downs and the stability to be the thing holding it up. And we do feel encouraged that we can keep up with the laws of physics, but the timeline was mainly driven by the laws of physics. So we're just going to keep following it.
Okay, thank you. And our next question comes from Philip Orgzelski. I do apologize if I mispronounced your name. I'm calling from Polish TV channel. Your line is now open.
Hello, Filip Orgzelski from the Polish Public Television Science Channel. First of all, congratulations to all of you from our director and our Science Channel team. And do we know what would be the next target for the telescope? Another star or maybe some deep space object? Thank you.
So this is Marshall Perrin. The target will remain, we'll use stars throughout the telescope alignment process, but we'll be switching to a different star as we do throughout. We started off with a very bright star for Webb so that we could use short exposures as we search this very large area. And we'll be moving to progressively fainter and fainter stars as we bring the telescope into alignment. And those probably be dozens of stars we use as we go through the rest of the commissioning process, at least a dozen stars. Of course, we have both brightness for each of the instruments has their own particular type of star, brightness of star that we use. So we really prefer not to focus on, the specific stars. In fact, for the one that we used for first light, we had half a dozen such stars that we could have used depending on the day of year that we launched. Deep space objects will wait until the science observations and the science commissioning on the other side beyond once we've completed the telescope alignment.
Okay, thank you. And as of now, there are no further questions in the queue.
All right, well then thank you very much. If we don't have any further questions, then we can go ahead and wrap up today. But if you do have any follow-up questions or anything that we didn't get to, please feel free to follow up with our team. The media team will get back to you. So thank you today to our speakers, to all those who dialed in. We'd encourage you to continue following along on our blog at blog.nasa.gov/web to hear more about some of these coming steps in Webb's alignment process. Thank you very much.
And thank you again for joining on today's call. You may disconnect at this time.